based sampling in digital signal processing. See, sampling is the process of converting continuous time signals into discrete time signals. The continuous time signals are images, videos are converted into in terms of discrete time signals, right? Now let us discuss about briefly the design thinking based sampling in digital signal processing. See, design thinking is of 5 stages, that is nothing but empathy, define, ideate, prototype and testing. Now let us discuss briefly.
Design thinking is a problem-solving approach that focuses on understanding the users, challenging assumptions, and creating innovative solutions. Sampling is the foundational step in digital signal processing, where continuous time signals are converted into digital discrete time signals by measuring their values at regular intervals. The continuous time signals include images, sound waves, or physiological signals. If sampling is not performed correctly, it can lead to distorted or incomplete signal processing. Therefore, understanding the principles of sampling is crucial for all DSP applications, from mobile communication to industrial systems. Thank you.
Now the empathy part. Empathy is the first step in design thinking. It is a problem statement. It is a problem statement of a specific phenomenon. For example, in the first step, understanding the users, engineers studies how people are using DSP systems on their real-time applications, and identifying their needs by consulting with professionals like audio engineers, doctors, aerospace experts to learn what is important for their work, and finding the points by discovering problems like poor sound quality, inaccurate signals, and weak radar detections by mainly ensuring the accuracy is the goal to capture signal clearly and reliably. By improving the usability, the steps ensure that DSP systems work well in the real-world applications, making them more effective and user-friendly.
So next step is define step. Once the user challenges are well understood, the next step is to clarify the define the problem. In DSP sampling, the problem often revolves around determining the optimal sampling rates. Understanding the sampling leads to analyzing where the high frequency distorting the signal. Oversampling on other hands, resulting in unnecessary large data size, increased memory usage, and heavier processing loads, which may not be practical for the real-time applications. Defining this balance as a problem statement helps guide to give a solution in a structured manner. Thank you.
Next stage is ideate. In this, the general possible solutions in creating a prototype. So for this, the Nyquist unknown filtering. In this, sample the signal at least 2 times for high frequency present in it, helps to reduce the loss of information. In anti-aliasing filtering, remove the unwanted high frequency and noise interference so that it can also prevent aliasing. It's nothing but overlapping, and the analog filter is applied before the signal. And the third is adaptive filter. In adaptive filter, sampling rate changes dynamically based on complexity. Then in this saves memories and process data regarding to the simple of signal it present in it. Then in oversampling and decimation, sample at high rate initially is oversampling, and it reduces the complexity. At filtering is known as decimation. It improves the data and reduces the final data load. So the techniques to design a role and efficient DSP system.
So I'm going to tell about test stage. So test and prototype. So it is not just about measuring accuracy, but also validating the solutions in real world conditions. So engineers compare sample signals with their original analog counterparts, measuring metrics like signal to noise ratio, total harmonic distortion, and root mean square error. So more importantly, they gather user feedback. In audio DSP, users are asked to listen to recordings and rate clarity, loudness and distortion. In medical applications, doctors and technicians evaluate whether signals are reliable enough for diagnosis. Testing also includes stress testing in different conditions such as varying temperature, device processing loads, and signal variability. If sampling solutions do not meet expectations, adjustment made either by tweaking filter designs, adjusting sampling frequencies, or optimizing processing algorithms to ensure robust performance.
So let me conclude. So following design thinking approach for sampling in DSP ensures that the solutions are not technically correct but also human-centered, efficient and reliable. It results in audio systems with crystal clear playbacks and recordings, and medical systems capture vital signals with high fidelity, and in communication system it transmits signals without distortion or data overload. It also ensures that designers could consider the resource constraints of embedded system that resulting in real-time signal processing. In essence, combining design thinking with DSP sampling bridges the gap between complex mathematical theory and real-world applications, making technically more useful, accessible and reliable for end users. Thank you for giving this opportunity for discussion.